So, have you ever found yourself doing some seemingly simple task in a web application?
Mm.
Maybe you're editing a shared document or tweaking an image or exporting a monthly data report for your team.
Oh, yeah, like a routine export,
Exactly. And you click download to save the file, you open it up to double check it, and you immediately spot like a tiny typo in the header.
right, which always happens.
Always. So naturally, you go back to the web app, you fix a typo, and you hit the download button again. But then, 5 minutes later, you find another error.
Yep, and you repeat the process.
Right, you repeat the process. And before you know it, you open up your computer's local downloads folder, and it is just an absolute disaster zone.
It really is.
You're staring at this cluttered, chaotic mess of files named report, report 1, report 2, all the way down to report 14.
It is basically the digital equivalent of a junk drawer, and I mean, we all secretly hate it.
We really do.
We treat our physical workspaces with so much care, but you open the average user's downloads folder, and it's just this graveyard of redundant data.
Yeah, a total graveyard.
Because you only ever wanted that one single file updated.
Yeah.
But your operating system just insists on preserving every single microscopic iteration of it. It just eats up your storage space and, honestly, your patience.
It drives you completely crazy because it feels like the computer is just, well, it's fundamentally misunderstanding your intent, right?
Exactly.
But what if I told you that this completely relatable everyday frustration isn't just some weird quirk of your laptop?
Right. There's actually a reason for it.
There is. It's actually the visible symptom of this massive, heavily fortified, totally invisible wall that exists between your web browser and your computer's hard drive.
Which is wild to think about.
It is. And today, for this deep dive, we are going to look at how modern web developers are finally tearing that wall down, literally brick by brick.
And that's a shift that fundamentally alters our entire relationship with the internet. I mean, we are moving away from this era of websites acting like isolated magazines we just flip through.
Right.
And we're entering an era where web pages possess the raw mechanical power of installed software.
Which brings us to the actual topic today. We're basing our discussion on a deeply fascinating technical blog post by Aaron Rose.
Yeah, it's a great piece.
It really is. It was published on tech-reader.blog, and it's brilliantly titled The Secret Life of JavaScript. The Sandbox.
Love that title.
So good. So our mission today is to explore that invisible boundary, understand the complex engineering that keeps it standing, and discover how this new frontier of code is bridging the gap so completely that web apps are actually beginning to feel exactly like native installed desktop software.
But we do need to point out that tearing down walls between the open internet and your local hard drive is inherently dangerous.
Oh, for sure.
There is this relentless tug of war in modern technology between giving users a seamless, powerful experience and maintaining the strict, uncompromising security needed to keep their personal devices safe.
Right. You don't want a random website rummaging through your stuff.
Exactly. When you start handing over the keys to the file system, the stakes get very high very quickly.
Right. So to really get into the mechanics of this, the author of the blog post, Aaron Rose, sets up this great little narrative scene.
A library scene, yeah.
Yeah. He places us in this grand, very atmospheric Victorian library in London. It's like the kind of setting where code quality is spoken about in these hushed, reverent tones.
Very dramatic.
Totally. And digital craftsmanship is the absolute only thing that matters. So in this library, we meet two developers.
Margaret and Timothy.
Right. There's Margaret, who is a senior software engineer. She's drinking dark roast coffee. She clearly knows her stuff. And then there's her junior colleague, Timothy.
And Timothy is visibly frustrated here.
Very frustrated because he is dealing with the exact cluttered folder problem we just talked about.
Yeah, so he's working on an export feature for a web app where a user needs to download a diagnostic log.
Right.
And the underlying code functions, I mean, it works, but the end-user developer experience is just terrible.
It's so clunky.
Because every time the user clicks export logs, Timothy's code generates the data and forces the browser to download a totally freight file.
Yep.
So if the user updates the log in the app and clicks export again 10 minutes later, they don't see their original file get updated. They just get, diagnostic-log1.txt.
Which is exactly what we were just complaining about. So Timothy is literally pulling his hair out.
Yep.
And Margaret just asks him the obvious question, why don't you just overwrite the original file when they click save the second time?
The logical question.
Right. But Timothy explains that to make this export work at all, he's relying on this notoriously rigid workaround from 2014.
Ah, yes. The anchor download attribute hack.
Yes, the anchor download attribute hack. And I have to admit, reading about how this hack mechanically works completely blew my mind.
It's pretty wild.
The developer literally writes code to create an invisible fake web link on the page. Then they take the file data, attach it to that invisible link, and write another line of code that programmatically forces the browser to, quote-unquote, click that fake link.
Right, an artificial click.
Yeah, and then they instantly delete the link so the user never even sees it.
And that invisible click forces a raw download action.
Wow.
So the browser grabs the data, packages it up, and blindly chucks it into the default downloads directory.
Just blind tossing.
Literally.
Yeah.
It is incredibly janky behind the scenes, but for years, I mean, it was the only way to get data out of a web application and onto a local machine.
You know, the way I was visualizing it while reading the post, it's basically like dealing with a really stubborn vending machine.
Okay, I like that.
Like, imagine you buy a bag of chips from a machine, you open it, take a bite, and you realize they are totally stale.
Gross, but okay.
Right, so you want to put the bag back in to get a fresh one, but the vending machine has absolutely no physical mechanism to accept anything back from you.
Right, it only dispenses.
Exactly. Every time you push the button for chips, it completely ignores the bag you are already holding in your hand and just drops a brand new, identical package on the floor.
Yep, that is exactly what the web browser is doing.
It's forcing this blind download. It's acting like the vending machine. But here is where I get a bit confused. Why does the browser act so dumb? Like, why can't Timothy's code just look at the hard drive, find the original log file, and overwrite it directly?
What's fascinating here is that the browser isn't actually acting dumb. It is acting paranoid.
Paranoid.
Yeah. Timothy actually mentions this to Margaret in the story. He calls it the walled garden,
Oh, right.
which is a foundational concept in web security. You have to remember what a web browser fundamentally is. It is an engine designed to execute completely untrusted code from total strangers all over the world.
Okay.
When you visit a website, you are downloading their JavaScript, their internal logic, and you're running it locally on your personal machine.
Which, when you frame it exactly like that, sounds like an absolute nightmare waiting to happen.
Oh, it would be. If that random code had direct access to your operating system's native file system, it wouldn't just be a nightmare, it would be the end of the internet.
Seriously?
Absolutely. Because a malicious website could just silently read your private tax returns or quietly overwrite critical system files, or even worse, encrypt your entire hard drive and hold it for ransom.
Oh, wow. Yeah, that's terrifying.
Exactly. So to prevent that, browsers were built as a walled garden, which is often called a sandbox. The browser running the JavaScript doesn't even know you have a C drive or a documents folder.
It's just blind to it.
Totally blind. It operates in a completely fabricated virtualized space. It is legally, well, in a software sense, blind to your hard drive.
So the code is basically trapped in a padded room.
That's a good way to put it.
It can play around with the data inside the room, it can show you pretty graphics on the screen, but it absolutely cannot get out into the rest of the house.
Right. The browser intentionally isolates itself from the operating system. And because of this heavily fortified wall, the browser treats every single export click as a completely isolated, brand new event.
Oh, I see.
It has absolutely zero memory of the file it just gave you 10 minutes ago because it's literally not allowed to look at your hard drive to verify if it's still there.
Wow.
It treats the environment like a simple document viewer.
Okay, so we obviously don't want random websites rummaging through our personal folders. That makes total sense. But as Margaret points out to Timothy in the story, maybe the engineering community has become a little too complacent.
Yeah, she calls him out on it.
She does. She asks him, is it still a walled garden? Or have you just stopped checking the gates to see if they can be opened?
And she's right, because the security model of the web hasn't just stayed frozen in 2014. The massive wall is obviously still there to block the ransomware and the malicious script.
Right, thankfully.
But modern engineering has installed some extremely specific, highly secure gates.
Okay, let's unpack this, because this is where the narrative shifts. Margaret steps up to a whiteboard in this atmospheric library. She picks up a marker, and she writes a single function on the board. Show save file picker.
The magic words.
Right. And she explains that this function is part of a relatively new architecture called the File System Access API. But wait, If the browser is a walled garden built explicitly to prevent untrusted code from touching the hard drive, how does this show save file picker thing bypass the wall without breaking all those strict security rules we just talked about? Does it, like, punch a hole in the wall?
Not a hole. Think of it more like hiring a specialized plumber to fix a sink in your house.
Okay.
You don't just hand the plumber the master keys and the deed to your property and tell him to wander around freely, right?
No, definitely not.
You unlock the front door yourself. You physically escort them to the one specific bathroom that needs fixing. You point at the sink and you say, you are only authorized to touch this specific pipe.
Oh, that makes perfect sense. So it's like a secure VIP handshake. Instead of tossing a generic file into a massive crowd, which is your downloads folder, you're explicitly asking the bouncer, which is the user, for permission to access one specific VIP room.
Exactly. The old 2014 hack was basically tossing flyers over the fence. But the File System Access API is the escort.
I love that.
When the web application triggers that show save file picker function, it pauses everything and asks the user for explicit permission.
So the user is in control.
100%. The user navigates to a folder, selects a specific file, and essentially acts as the escort. And once the user makes that choice, the operating system issues something called a persistent file handle to the JavaScript engine.
A persistent file handle. So the code is finally handed a secure VIP pass to that one specific sink and literally nowhere else.
Right. The wall briefly parts, but only for that specific user-authorized file. The browser still has no idea what else is in your documents folder. But once it has that handle, it can open a writable stream.
Okay, let's pause on writable stream. Because in the context of the messy downloads folder, what makes a stream different than just dropping the file normally?
It changes everything about memory and efficiency.
How so?
Well, under the old system, the browser would take the data, package it into this massive, clunky block of memory called a blob, which literally stands for binary large object, and dump the entire thing onto the hard drive all at once.
That sounds heavy.
It is. If you were exporting, say, a massive video file, holding that giant blob in the browser's memory could actually crash the whole tab.
Oh, I've definitely had that happen.
Right. But a writable stream, however, is an open pipeline. It doesn't drop a monolithic package. It holds onto that secure file handle, opens a connection to the hard drive, and actively funnels the data, byte by byte, into the existing file.
So the next time the user hits export logs, the app uses the handle it already has, opens the stream, and actively rewrites the data inside the original file. No more duplicate files, no more diagnostic-log or to.txt falling out of the vending machine.
It's an elegant, native-feeling mechanism that respects both user intent and system resources.
It sounds like the absolute perfect magic bullet to solve Timothy's nightmare, but you know, whenever we encounter a magic bullet in technology, there is almost always a catch.
Always.
And Timothy spots it. He's amazed by this whiteboard revelation, but then he pauses and asks Margaret a really critical question. Wait, what if a user is on Safari or Firefox? Do they support it yet?
And that is the million-dollar question.
Margaret brings him right back down to reality and welcomes him to the bleeding edge.
Right, it's because the bleeding edge of web development is where the most brilliant innovations happen, but it is also a notoriously fractured environment.
Here's where it gets really interesting. Margaret admits that right now the File System Access API is primarily supported in Chromium-based browsers, so like Google Chrome and Microsoft Edge.
Yeah.
But for the rest of the web ecosystem, specifically Safari on Apple devices and Mozilla's Firefox, the wall is still firmly up. They outright refuse to support this persistent file handle architecture.
They do.
So I have to push back a little on Margaret's brilliant whiteboard session here. If this API only works on Chrome and Edge, doesn't implementing this mean that Timothy's web application just completely breaks for anyone using Safari or Firefox?
That's a valid concern.
Like, doesn't that create a class system on the internet? The Chrome users get the premium native experience, and the Firefox users just get a broken button that feels like incredibly lazy developing.
Well, if we connect this to the bigger picture, it would be lazy if they simply rolled it out blindly.
Okay.
The reason Safari and Firefox are holding out isn't because they lack the technical capability, by the way. It's a philosophical battle over that walled garden.
Oh, really?
Yeah. Apple and Mozilla are incredibly concerned about the security implications of handing over file handles, even with user permission.
Because it's a slippery slope.
Exactly. They worry about malicious sites tricking users into overwriting critical files or, using those persistent handles to track users across the internet, which is a process known as fingerprinting.
Wow, I didn't even think about tracking.
Google, on the other hand, runs Chrome OS. Their browser literally is an operating system for millions of Chromebooks. They desperately want web applications that have the power of native desktop apps, so they are pushing this API hard.
Okay, that makes total sense. Google needs the web to act like a desktop, and Apple wants to keep the desktop and the web strictly separated for privacy reasons.
Precisely.
But philosophical battles aside, what actually happens to Timothy's code? If a Firefox user clicks export, does the application just throw an error and crash?
No, and this is where Margaret corrects Timothy's understanding of software craftsmanship.
Oh, okay.
She explains that a master developer doesn't just write modern code and hope for the best. They use a foundational technique called feature detection.
Feature detection. Okay, let's dig into how that actually works under the hood. Does the code literally ask the browser what brand it is?
No, it doesn't check the brand name, because honestly, that can be spoofed.
Oh, good point.
Instead, it checks the browser's literal memory capabilities.
Yeah.
The JavaScript looks at something called the window object.
The window object.
Yeah. Think of the window object as the browser's master ledger of everything it currently knows how to do.
Like a directory.
Exactly. So before Timothy's code ever tries to export a file, it pings the ledger. It basically says, "Hello, browser. Before we begin, do you have a definition for show-safe file picker in your memory?"
And then what?
If the user is on Chrome, the browser checks the ledger and says, "Yes, I know exactly what that is. Proceed."
But if they are in Firefox, the browser checks the ledger and says, I have absolutely no record of that function.
Right. The ledger comes up blank.
Mm-hmm.
And because the application detected that the modern feature is missing, it gracefully shifts gears.
Gracefully.
Yes, it falls back to the legacy pattern. The code says, okay, the new pipeline isn't available, so we will just construct that invisible link, attach the bulky data blob, and use the old 2014 Anchor download hack.
Oh, wow. So the Safari user still gets their diagnostic log.
Exactly.
They might still get the messy document1.txt in their downloads folder, but the button fundamentally works. The app doesn't crash.
The Safari user receives the standard functional web experience they've always known. But the Chrome user gets this elevated, seamless, native desktop experience.
That's brilliant.
You aren't punishing users on older or more conservative browsers. Instead, you are progressively enhancing the experience for those whose systems can handle the bleeding edge.
I really love that concept of progressive enhancement. It feels like a very responsible way to build things.
It is.
So armed with the knowledge of how to check the ledger and use the right gate, Timothy is finally ready to rewrite his code and fix his user experience.
Finally.
According to Aaron Rose's blog post, Timothy completely scraps his old legacy download logic. He taps into the window object to do that feature detection. He invokes the file picker when it's available, and he leverages the new streaming architecture to pipe the data straight to the disk.
A total rewrite.
Yeah. So I want to make sure we really synthesize what this looks like for the person actually sitting at the keyboard. Can you paint the picture for the listener? What exactly happens on click number 1 versus click number 2 now that the code is updated?
Sure. Let's walk through the exact user journey. So, click number 1. The user hits the export button on the web app.
Okay.
Under the old system, the file would just silently drop into the downloads directory. But now, because of the File System Access API, a native operating system save dialog box appears right in the center of the screen.
The exact same familiar window you'd see if you were saving a spreadsheet in Microsoft Excel or a photo in Photoshop.
Yes. It looks and feels identical to a native action. The user navigates to their Documents folder, creates a new folder for this project, names the file system diagnostics, and clicks Save.
And that's when the magic happens.
Right. At that exact microsecond, the operating system issues the persistent file handle. The data streams seamlessly into the folder, and the file is saved perfectly.
Okay, that's click 1. Now let's say it's 10 minutes later. The user has been working, the diagnostic data has updated on the web page, and they need to export it again to reflect the changes. They click the export button for the second time.
On click number 2, there is absolutely no prompt.
None at all.
Nope. No native save dialog pops up to interrupt their workflow. And most importantly, there is no duplicate file created in the directory.
Thank goodness.
Because the web app retained that persistent file handle from click number 1, it knows exactly where that specific file is, and it already has the explicit permission required to touch it.
That is so cool.
It is. The JavaScript engine securely opens that OpenPipe writable stream, and it funnels the new data directly into that exact same file, quietly overwriting the old contents in the background.
It's totally seamless, which is exactly how we expect traditional software to work.
Exactly.
Like when I hit save in a word processor, I don't get a brand new text file every single time. It just updates the one I'm currently working on.
And that is the massive takeaway here. By utilizing the File System Access API and backing it up with smart feature detection, developers are fundamentally bridging the gap between web applications and operating systems.
Right.
We are bringing true native IDE capabilities straight into the browser window.
Okay, let's define IDE for a second, just so everyone is on the same page. That stands for Integrated Development Environment, right?
Yes, exactly. Think of complex, heavy-duty software like Visual Studio for coders or a massive video editing suite.
Got it.
Those are IDEs. And for decades, it was basically assumed you could never run software that complex in a web browser, simply because it required too much direct interaction with the local file system.
It was too heavy for the sandbox.
Exactly. But this API changes that calculus. It means the tools you use on the internet don't have to feel like disconnected, lightweight versions of quote-unquote real software anymore. They can interact with your local environment with the precision and efficiency of an app you installed from a CD-ROM 20 years ago. But they're backed by all the cloud-connected processing power of the modern web.
It really is a massive shift in how we perceive the internet. So let's briefly recap this journey for everyone.
Sounds good.
We started in a very familiar, deeply frustrating place, a cluttered downloads folder filled with 14 identical text files, all because the browser was acting like a walled-off paranoid document viewer.
The vending machine.
The stubborn vending machine. We looked at the 2014 hack, which forced developers to basically toss data over the fence in massive, inefficient memory blobs.
And then we watched as modern web development provided a highly secure, user-escorted gate through that wall.
Right. By utilizing a persistent file handle, the web app stepped out of the sandbox, secured explicit permission, and opened a continuous writable stream directly to the hard drive.
All while using feature detection.
Yes, checking the window object ledger to ensure that users on Safari or Firefox weren't left with a broken page. It's an incredibly elegant solution to a really ugly problem. So what does this all mean? When you pull back and look at this transition, it means that the line between a website and a desktop application is rapidly, visibly disappearing.
It really is.
You don't necessarily need to download a massive application installer anymore. The web browser itself is becoming the ultimate universal operating system.
It is an incredible evolution of the platform, but, and this raises an important question, it leaves us with a lingering tension.
What's that?
Well, we've spent this entire discussion marveling at how developers are bypassing the walled garden of the web browser, right? A garden that was originally constructed for the sole purpose of keeping us safe from malicious actors.
Right. The padded room exists for a very good reason.
Exactly. So if web browsers are now gaining the mechanical ability to reach out, secure persistent file handles, and establish open data streams directly to the personal files sitting on our hard drives, how will our definition of a safe web browsing experience have to evolve in the next 5 years?
Ooh, that's a tough one.
As developers build more powerful tools, and we as users willingly hand over more keys to the gates of that walled garden, where exactly do we draw the line between daily convenience and catastrophic vulnerability?
How much of our local machine are we willing to expose to the open web just to get rid of a few annoying duplicate files?
Exactly.
It's definitely something to keep in mind the next time a website asks for permission to access your device. Until then, you might just have to spend a few minutes cleaning out that cluttered downloads folder of yours. Thanks for joining us on this deep dive.